begin with something simple. Every time you look at the night sky, you are already looking into the past. The light from the moon takes about 1 second to reach you. The light from the sun takes 8 minutes. That means if the sun exploded right now, you would not know for 8 full minutes. You would still see sunlight, still feel warmth, still believe everything is normal. Because light needs time to travel. And that delay isn't just a fun fact. It's a rule that controls everything you will ever see in the cosmos. The universe does not allow for the instantaneous transmission of information. Every message, every flicker of a star must span the void at the speed of light. There are no shortcuts. The further away an object is, the more ancient its message becomes. This means the night sky is not a snapshot of the universe's present state. It is a collage of time, a tapestry of different eras and forgotten years, all arriving at your eyes in the same breath. Some galaxies we observe are billions of light years away. When we look at them, we are seeing them billions of years in the past. Distance in space is distance in time. A telescope is not just a machine that lets you look farther. It is a machine that lets you look backward. Modern telescopes, like the James Webb Space Telescope, are already pushing that boundary. They can detect galaxies that formed only a few 100 million years after the universe began. That means the light arriving at our detectors tonight has been traveling for more than 13 billion years. Now imagine something even stranger. What if you could move faster than light? Not a little faster, instantly. From Earth to a star 10 light years away. You arrive, you turn around, and what you see is not the Earth of today. You see Earth 10 years ago, because the light leaving Earth is still traveling through space. It hasn't reached your new location yet. So, the planet you see in the distance is not the present. It's the past. If you could jump 50 light years away, you would see Earth 50 years ago. Cities would look different. People you know might not even exist yet. Your parents might still be children. And if you traveled far enough, from dozens of light years away, you could watch a tiny moment in time. A small house, a quiet room, a mother holding a newborn baby. That baby is you. Keep going farther, thousands of light years away. Human civilization begins to disappear. No cities, no satellites, no airplanes crossing the sky, only forests, rivers, and early humans walking across the planet, travel tens of thousands of light years away. Now you see Earth before humanity. No history, no language, no tools, just animals and wilderness covering the planet. But space is vast. Keep going. Millions of light years away. Now Earth itself looks younger. The continents shift. The climate changes. Dinosaurs still walk the land. Jump even farther. Hundreds of millions of light years away. Earth becomes something far more violent. A world of fire. Volcanoes covering the surface. Oceans forming for the first time. And if you could travel far enough, farther than any human has ever imagined, you might see something almost impossible. The birth of everything. The moment when the universe itself exploded into existence. The Big Bang. Because every photon from that moment is still racing through space today. And if you were far enough away, you could watch the universe begin. Now imagine upgrading your telescope. You transform the entire Earth into a single optical instrument. With a lens that wide, you begin scanning deep space, past the stars in our galaxy, past the spiral arms of the Milky Way, past neighboring galaxies. You look deeper, 10 billion light years away, 12 billion, 13 billion, and something extraordinary happens. The deeper you look, the younger the universe appears. Galaxies become smaller, less organized, more chaotic, because you are watching them in their infancy. You are watching structure form. You are watching cosmic history unfold. You are watching the universe to learn how it became what we know today. Eventually, you approach a number, 13.8 billion years. That is the estimated age of our universe. And here, you encounter something that feels like an edge. Not a wall, not darkness, a limit. Scientists call it the observable universe. But that boundary is not what most people imagine. It is not a shell surrounding us. It is not a sphere we are sitting inside. Instead, it is a horizon defined by time. If the universe is 13.8 billion years old, why isn't the observable universe only 13.8 billion light years wide? Because space itself is not standing still. Space has been expanding the entire time. So, the light we receive today may have started its journey 13 billion years ago. But the galaxies that emitted that light are now much farther away than 13 billion light years. That's why the observable universe extends about 46 billion light years in every direction, meaning the full observable diameter is about 93 billion light years. Beyond that distance, we cannot see, not because our telescope is too small, but because light from beyond that region has not had enough time to reach us. You are limited by time itself. Even a planet-sized telescope cannot defeat the universe's speed limit. It only helps you reach it faster. The universe is expanding, not into empty space. Space itself is stretching. The farther away a galaxy is, the faster it appears to move away from us. At extreme distances, some galaxies recede faster than light. They are not breaking physics. Space itself is expanding between us. Eventually, you reach a faint, uniform glow, the cosmic microwave background, discovered in 1965. This radiation is about 13.8 billion years old. It is the oldest light we can detect. Before that moment, the universe was opaque. Even light could not escape. So the edge you're searching for is not a place, it's a time. So does the universe have an edge? Here is the uncomfortable truth. We do not know. The observable universe has a boundary, but the universe itself? It could be infinite or finite, but unbounded, like the surface of a sphere. Imagine standing on the edge of an ocean at night. You stare at the horizon. It looks like a boundary. But if you sail toward it, you never actually reach it. It moves with you. The observable universe works the same way. Because of dark energy, some galaxies we see today will eventually disappear from view. Future civilizations might look out and see only the Milky Way and conclude that their galaxy is all that exists. They would be wrong, but they would have no way to know. Even a telescope the size of Earth would face the same limit. Not a wall, not a barrier, a moment. The moment the universe first became transparent. The moment light began its journey. You are not searching for the edge of space. You are searching for the boundary of time. If this changed the way you look at the night sky, like the video, subscribe. Next week, we ask a more dangerous question. If Earth's destruction became inevitable, and humanity had no choice but to leave, what would life on Mars actually look like? And how would it change everything you know about living, breathing, and being human? See you next week.